Here's something that will blow your mind. jQuery is running on over 77% of all websites on the internet right now. That's more than React, Vue, and Angular combined by a factor of 10. But here's what's even crazier. I've been diving deep into jQuery source code, and I discovered that almost everything you think you know about how it works is wrong. Today I'm going to show you the hidden architecture behind one of the most influential pieces of software ever written. We are talking insider secrets that 99% of developers, including the ones who use jQuery daily, have never seen. And stick around to the end because I'm going to reveal how jQuery solved problems in 2006 that JavaScript didn't solve until 2015. Let's go. Now, before we dive in, I want to be clear about something. I've spent years working with JavaScript libraries, building them, debugging them, and reverse engineering them to understand how they tick. I've gone through jQuery source code line by line, traced through its build system, and I found things in there that legitimately changed how I think about software architecture. What I'm about to show you isn't just trivia. These are design patterns and solutions that are still relevant today. Patterns that influenced React, Angular, and the JavaScript language itself. So let's just start with the biggest misconception of all. When you write jQuery function div, what do you think is happening? Most developers think I'm calling a function that selects elements. And sure, that's what it does, but that's not what it is. Here's the secret. The $sign function is actually calling a constructor function called init, but here's where it gets weird. And this is the first mind-blown moment of the video. Every time you call $sign function, jQuery creates a new object for you. It's not returning elements directly, it's wrapping them in a special jQuery object. But wait, if init is the constructor, how does it have all those jQuery methods like .addClass or .height? This is where John Resig, jQuery's creator, pulled off something brilliant. Deep in the source code, you will find this line: init.prototype equals jQuery.fn. He is reassigning the prototype of the init function to point to jQuery's prototype. This means when you create a new jQuery object, it automatically inherits all of jQuery's methods, even though you never explicitly created a jQuery instance. This is a design pattern called the factory pattern with prototype delegation, and it lets you write $sign function div instead of much uglier new jQuery div. One line of code, infinite convenience. Quick question, did you know this? Drop a comment below. I'm genuinely curious how many developers have seen this pattern before. Okay, so we know $sign function creates a jQuery object, but how does jQuery actually find elements? You might think it calls query selector all and calls it a day. And for modern browsers, yeah, sometimes it does. But here's what's happening under the hood that makes jQuery selector engine genuinely brilliant. When you write a selector like $sign function div.active and pseudo class of first child, jQuery doesn't just throw it at the browser. It goes through a sophisticated process called tokenization. First, the selector gets broken into chunks called tokens. Div, that's a tag token, .active, that's a class token, and first child, that's a pseudo token. Each token type has its own regular expression for matching and pre-filter function for validation. But here's the insider knowledge that very few people know about. jQuery maintains a token cache. Every time you parse a selector, the tokenized result gets stored. The next time you use the same selector, jQuery skips the entire parsing process and grabs it from cache. The cache uses a clever trick. It stores maximum 50 entries, and when it exceeds that, it deletes the oldest entry. This is a basic LRU, least recently used cache implemented in about 10 lines of code. But here's where jQuery really earned its reputation. Back in the day, and honestly even now in edge cases, different browsers implemented query selector all differently. Internet Explorer had bugs where enabled and disabled pseudo classes matched weird elements. Empty attribute selectors didn't work. Certain pseudo classes just broke. jQuery has a file called rbuggyQSA.js that literally catalogs these browser bugs and works around them. When jQuery detects it's running in a buggy browser, it patches the behavior. This is why jQuery became essential. It wasn't just about convenience, it was about survival in a fragmented browser landscape. Pause for a second. Every time you have written a CSS selector in jQuery, this entire system fires up. Tokenization, caching, cross-browser bug detection, all happening in milliseconds. You still think jQuery is just a wrapper? Alright, let's talk about something that seems simple but absolutely isn't. Inserting HTML into a page. When you write something like $body.append a table, what actually happens? First, jQuery doesn't just dump that string into inner HTML. It goes through a function called build fragment that converts your HTML string into a document fragment, a lightweight container for DOM nodes that isn't actually attached to the page yet. But here's where it gets interesting. jQuery maintains something called wrap map. You see certain HTML elements have rules about where they can exist. A TD element, it must be inside a TR, which must be inside a tBody or thead or tfoot, which must be inside a table tag. If you try to create a lonely TD using inner HTML, browsers will either reject it or produce garbage. jQuery looks at the first tag in your HTML, wraps it in the appropriate parent structure, creates elements, then unwraps just the part you want. Mind blown. But wait, there is something even more clever happening with scripts. When you inject HTML that contains script tags, you have got a problem. Those scripts might exaggerate before the rest of the HTML is properly inserted into the DOM. jQuery has internal functions called disable script and restore script. It temporarily changes the script type to something the browser won't exaggerate, inserts all the HTML, then restores the type and evaluates scripts in the correct order. This is a surgical precision DOM manipulation. jQuery also tracks whether scripts have already been evaluated using a private data property called global eval. This prevents the same script from running twice if you clone elements. This is the kind of detail that separates from libraries that work everywhere all the time without weird bugs. Okay, here's the historical bombshell that most developers don't know. jQuery had promises 6 years before JavaScript added them to the language. In 2009, jQuery 1.5 introduced a deferred object. Native JavaScript promises weren't standardized until ES 2015. And here's the thing, jQuery's implementation actually influenced the promises specification that all modern promises are based on. The jQuery deferred system has 3 states: pending, resolved, and rejected. It supports progress notifications, something native promises still don't have, and it has a .end method that allows chaining. But here's the insider detail that most people miss. jQuery includes something called exception hook in its deferred system. This catches errors that happen inside deferred callbacks and warns you about them. Without this, errors could be silently swallowed, a problem that plagued early promise implementations. And there is a .when which lets you wait for multiple deferred to complete. This is essentially promise.all invented in jQuery land years before the standard. If you're enjoying this deep dive, hit the like button. Seriously, it helps more people discover this kind of content. Okay, back to the good stuff. jQuery's AJAX system is probably its most famous feature, but the implementation is way more sophisticated than most people realize. As its core, jQuery's AJAX isn't just wrapping XML HTTP requests, it's an entire transport layer abstraction. jQuery has multiple transports for different types of requests: XML HTTP requests for normal requests, a script tag injection for cross-domain scripts, JSONP for cross-domain JSON before cores existed. Speaking of JSONP, let's talk about how that actually works, because it's absolutely wild. JSONP stands for JSON with padding, and it was the hack that made cross-domain data work before browsers supported cores. jQuery generates a unique callback name using jQuery.expand and a nonce. It injects this callback name into the request URL. It creates a temporary global function with that name. It injects a script tag pointing to the URL. The server wraps its JSON response in that callback function. The browser exaggerates the script, which calls jQuery function. jQuery captures the data and cleans out the global function. This is brilliant engineering for a terrible situation. JSONP was a security nightmare, but it worked, and jQuery made it seamless. Modern jQuery also handles binary data intelligently. When you send form data, jQuery automatically disables processed data so it doesn't try to stringify it, sets content type to false, letting the browser set the proper multi-part boundary. All this happens in prefilters, functions that process requests before they are sent. Let's talk about something that seems that simple, and setting CSS properties. They are easy, right? Just set a style. What could go wrong? Everything. Different browsers use different vendor prefixes: WebKit transform, Moz transform, MS transform, O transform, and finally JAWS transform. jQuery has a function called final prop name that figures out which version of CSS property that the current browser actually supports. It tests against the browser's style object and caches the result. But here's something even cooler about jQuery's CSS handling. When you call .hide on an element, jQuery doesn't just set display none, it remembers what the display value was before. If your div was displayed inline block before hiding, jQuery restores it to inline block, not just block. There is even a function called getDefaultDisplay that creates a temporary element of the same type to figure out what the browser's default display value is for the tag. It then caches this per tag name. This is the level of detail that made jQuery just work. And there is swap, a function that temporarily changes CSS properties, runs a callback, then restores them. This is used internally to measure elements that are hidden. Because hidden elements have 0 dimension, functions, but sometimes you need to know their natural size. Here's a problem that plagued early JavaScript development: memory leaks. Old browsers, especially Internet Explorer, had garbage collection bugs. If a DOM element referenced a JavaScript object and that object referenced the element back, neither could ever be cleaned up. jQuery's solution is elegant. Instead of attaching data directly to DOM elements, it uses an expando system. Each element gets a tiny unique identifier, just a number. The actual data is stored in a separate JavaScript object, keyed by that number. This means minimal data on the DOM element itself, no circular references. When the element is removed, the data can be cleaned up separately. jQuery actually maintains two data stores: data pref for internal jQuery data like event handlers, data user for developer attached data via .data. This separation ensures jQuery's internal bookkeeping never conflicts with your data, and jQuery's .data method integrates with HTML5 data attributes. jQuery reads these attributes, parses them intelligently, including JSON, and caches the result. Let's peek behind the curtain at how jQuery itself is constructed. jQuery isn't written as one giant file. It's composed of dozens of modules: core module, object construction and utilities, AJAX module, AJAX functionality, CSS manipulation, animations in the effects module, event module has event handling, and many more. The build system uses rollup to bundle these modules together. But here's the interesting part. There is a slim build of jQuery that excludes AJAX functionality, animation effects, deprecated methods. To accomplish this, jQuery uses a custom rollup plugin called rollup file overrides. Instead of removing modules which would break dependencies, it replaces their content with empty exports. This is clever because it maintains the module interface while removing the implementation. The build also dynamically stamps version information: package version from package.json, git commit hash, build date. This is embedded directly in the output, so you always know exactly which build you're running. And here's something wild about jQuery's release process. They have a verification script that builds jQuery locally, downloads the version from CDN, downloads the version from npm, computes SHA to 156 hashes, compress them byte for byte. If anything differs, the release is rejected. This ensures what's on your CDN is exactly what was built and verified. jQuery predates modern JavaScript modules. It was created when global variables were the only option, but today jQuery works with everything. For AMD, asynchronous module definition used by require.js, for common.js, node.js, and bundlers for ES modules. And there is still jQuery.noConflict method, a function that releases the $value variable back to whatever had it before jQuery loaded. Before jQuery loaded, it saved the current values of $, and jQuery noConflict restores them. This was essential in an era when multiple libraries fought over $. If you made it this far, you're clearly someone who appreciates understanding how things actually work. I create deep dive content like this regularly, dissecting libraries, frameworks, and language features that most tutorials just skim over. If you found this valuable, hit subscribe and ring the bell, and drop a comment telling me what library or technology should I dissect next. So here's the thing about jQuery. People say it's just a wrapper, people say it's obsolete, people say vanilla JavaScript can't do everything now. But what we have seen today is something different. jQuery isn't just a library, it's a museum of solved problems. Cross-browser selector bugs, solved. DOM manipulation edge cases, solved. Async handling before promises, solved. Memory leak in old browsers, solved. Module compatibility, solved. And hey, if you want to go even deeper, I'm leaving links in the description to jQuery source code and some of the specific files we discussed today. Happy exploring!